Hello guys, Ganesh here. Welcome back to the lecture series of automotive design. Till this video, we have seen the manufacturing process and what are trends, what are the basics of automotive design. Okay, so how the plastic parts will be going to be manufactured, and what are the design considerations that we should keep in your mind while making the plastic parts. Okay, so all things we have seen it, and we have seen about the core and cavity. Okay, we have seen what is class A, what is class B, and what is class C. All those things we have already seen, and we have seen that in sketcher workbench. Okay, we have seen more about CATIA, and we seen how we are going to use in the surface design workbench. Okay, we have seen every single tool and how can we use them, and we have seen the manufacturing related issues also. Okay, the core and cavity, what is core and what is cavity, and we have seen the design considerations, the draft angles and the tooling axis. Okay, hope you guys okay, as discussed the generator shape design workbench in CATIA, we have discussed every single feature that we, so what are the features that are not covered. We will be seeing them while doing the exercises. Okay, so let's put all the knowledge that we have gained up to here. So for making one plastic part, okay, which is a simple part, so I'm going to click on file, open. So the switch bezel part, okay, I'll be providing the link of this file in a OneDrive, okay, and I will paste that OneDrive link in the description box itself. You can access them right from there itself. Okay, so let's put all the knowledge that we have gained up to now. Okay, this is my part. Now this is my class A surface. What does it mean? This is the outermost surface. That means it has to be appear outside. Okay, whenever I see sitting in the car, so I can see it directly, or I can even touch it. Okay, so that is what the class A surface. When I'm touching or seeing it, it should be looks like, okay, it is very good aestheticness, right? So the class A surface is modeled in that way. Okay, we don't have to control, we don't have any control over it. Okay, only thing is the class A, we cannot manufacture the zero thickness parts, right? Zero thickness parts we cannot manufacture, right? So that's why, imagine this is a plastic part. I'm going to manufacture it. I'm going to model the part in a manufactured feasibility. So what I have to do is, first thing, I need to check in which direction the core and cavity can be made. So although you're not going to design the core and cavity part also, okay, you need to specify the direction. Okay, that is why you have to choose the tooling axis. So tooling axis is nothing but the core and cavity will move each other along with that axis only. Okay, you are specifying that. Okay, but when you are specifying the tooling axis, so you cannot specify it blindly, right? I told you in the tooling axis session. Okay, whenever you are choosing the tooling axis, you should cover all the draft faces. Okay, so how can it covers? So let's see in this direction. So if I have a draft, like if I have a tooling axis like this at this point, okay, I can cover all this surface, all the patches. So that will be my tooling axis, right? So let's create that. Okay, so the most basic way is, so let's click a point and put a point at mid of this line, mid of this edge, midpoint. Click on OK. Let's click let's add one more line with a point and direction option. Set the point and the direction Z component. Okay, this can act as my tooling axis. Okay, I have to check. So imagine the core and cavity designer have designed the core and cavity for this plastic part by taking the reference as this line. So okay, I'm not done any draft analysis for this. So if the mold designer have done the core and cavity, definitely it would be having some problems, right? So let's know that problems also by draft analysis. Click on this draft analysis and click on this compass. Place the compass on your line, on your tooling axis, like this way, and lock it and choose the surface. It is showing red color, so let's flip it. You can see most of the faces are appearing in green color, but one face is showing in blue color. Okay, initially it is showing in the red color. So let's see the what does it means the red color, green color and blue color. You can see the palette here. What are the faces that are having the more than 3 degrees of draft angle according to this axis are appearing in red color, are appearing in green color. So there is no problem with the green surfaces because they are having the draft angle of more than 3 degrees and which can be manufactured easily. Okay, our problem is with the red color and blue color surface, blue color faces only. Okay, whenever you seeing the blue surface, what does it means? You can change the angles of these also. Okay, I'm not going to changing now. So whenever you're seeing the blue color surface, what does it mean? The draft angle of this particular face is 0 to 3 degrees. We have seen that less than 3 degrees of draft angle, what will happen? It will cost. It will tends to more cost, right? So which is a thing that we have to avoid also. Okay, and at the same time we shouldn't give the more than 10 degrees draftness also. Okay, the red color which is highlighting that, which is completely opposite of your tooling axis, tooling feasibility. Okay, so what does it mean by red color? All faces are having the draft angle below 0 degrees. Okay, that means if the part is 0 degrees draft angle, it cannot be. See, when I flip it out, it is showing the entire surface as a red color. So this is fine, but imagine some faces are highlighting in red color and some faces are highlighting in green color. So that is what the problem we have. Okay, either we need to change the tooling axis. So right now in our case we have one face like that. We have to change the tooling axis for that. So let's click on the cancel. So this tooling, okay, this tooling line is not going to be useful to me. I'm deleting it. So what I'm going to do is, so I need to keep a tooling direction in separate geometrical set. Okay, so why I'm doing this, you will be understanding every single you will be understanding that why I'm keeping the every single entity, every single operation in a separate geometrical set at the end of this tutorial. Okay, now let's insert one more geometrical set with a name, tooling direction. Okay, this point also I need to keep in tooling direction. You can change the tooling direction, you can change the geometrical set of a particular feature like this way. Okay, right click and make sure it is defined in our object. Okay, now let's create one more. So initially we have done one line according to this jet axis, so which is not going to be useful to us. So the same process that I cannot use now. So what I'm going to do is I'm just inserting on axis system. Click on the insert axis system, select this point, click on OK. Okay, now let's create a point sketch here. Sketch projection point. Select this point and reverse way, click on OK. Let's create one line. Okay, okay, let's give as 5 degrees. Okay, okay, this can be my tooling axis. Okay, let's check the draft analysis for this. Lock it, select the surface, flip it. Right now you can see that initially what we got, the error, that blue surface, it is wrong now. So I can check the draft angle also. Click on this and select this. Which is having the 5 degrees. Okay, that's fine. And which is having 29 degrees. That is also fine. And this surface 17 degrees. Okay. So all my faces are more than 3 degrees of darkness. So okay. So I need to create the draft analysis, the report also. So as this, I can choose my compass, place here, unlock it, select the surface, and click on OK. Okay. In your tree structure, you can be seeing that the draft analysis tab. Okay, draft analysis. Okay, right now I'm not going to using any of this, so let's hide it. Okay, let's hide this compass and all these things also. Okay, this is my tooling axis. I want to distinguish it from other things. So what I do, so select the tooling axis. Let's rename this as first tooling axis. Enter. Okay, let's change the color of this line and change the line weight of this line and even the type of this line. Okay, now in this case I can easily understand this. Okay, it is my tooling axis. Okay. Okay guys, so I'm going to using one option called publication. So what is going to be useful for me? Imagine I'm having the large tree structure. Okay, I'm working at the bottom of that tree structure and I need to access the class A surface. So what I have to do, I need to scroll up entire the way to the class A, and there I have to hide it or unhide it or even expand. I have to select the class A, right? So that is a little time consuming and even irritating process also. Okay, we are not going to doing like that. So what we are going to do is, so select the class A surface and use an option called publication. Yes, click on OK. Okay, what does the publication tool does? It will keep a separate tree structure for a publication tab. Okay, whatever the things that you have added in the publication, those are appeared separately. Okay, you can see that the class A, I can access the direct surface even without expanding the geometrical set. Okay, that is the use of the publication tool. And similarly, I'm choosing the tooling axis also in this publication tab, because while creating the class C surface, we are going to using that. Okay, I don't have to expand the geometrical sets for accessing these two. Okay, since my tooling axis is correct, my draft angle is okay, so this class A can be manufactured. So let's start our modeling process. Okay, the very easiest step is see, this is a outermost boundary, so that means, so this is a part that you are going to see after manufacturing. Okay, so you need to create a surface which is at a distance of particular thickness. Okay, so how can we do that? So there is an option for that, offset, select this surface and choose the thickness. Let's consider it as a 3 mm. Click on OK. Okay, on which direction it is? Okay, we have started. Okay, undo it. We have started class B modeling, right? So I need to keep that separate geometrical set. Class B creation. Enter. Okay, make sure it is define object. Okay, let's click on this offset. Select this. Click on OK. Okay. Double click. 3. Enter. Okay, now which direction it has created, I'm not sure about it. So what I do, I'll just change the color of class B. You can see that I told you the class A is the outermost visible surface, but in our offset surface is creating beyond this. We don't want that. We want the offset surface should be inside of this class A. So let's change the direction. Okay, this is fine for me. The next thing, okay, class B creation, it is not created any problems. Okay, sometimes this all this fillet patches will create lots of problem. We are going to doing the multiple operations or while reaching the one edge. Okay, this is okay. If we want to check the class A continuity and class A surface, so what the feature? So boundary feature. Select the surface. It is not highlighting any disconnected boundaries. Okay, the class B is also fine. Okay, since my class B is okay, I'm going to creating the class C also. So how can we create a class C? So let's create a one more geometrical set, rename it as a class C. Creation, enter, and select the boundary feature, select all the outermost boundary. You can see that, right? In the class C itself we are having this mid patch. So what does it means? Let's cancel it. If you zoom it very closely, you will be seeing a gap there. I'll show you. See that gap? Okay. So since it is a very tiny gap, it can be resolved by using the join command very easily. Okay, we can neglect it. Okay, we don't have to worry about it. So what I'm going to doing is, for creating the class C surface, click on this boundary, select this. Okay, click on this boundary and select the outermost boundary, click on OK. Okay, now we need to create the class C surface. So we need to use the sweep option for this. Click on this sweep and select the curve. Okay, in the sweep we will be having one option called draft direction. Okay, now we are creating one class C surface with respect to this curve, and we should also have the draft angle according to this line. Okay, which should have more than 3 degrees of draftness. Click on preview, reverse direction, preview. I don't have to increase that much. Okay, let's increase the draft angle. Okay, up to 10 we can choose. Okay, it is creating the errors. Okay, we can, or else the feature that we work with, that we can do is sweep with the reference surface and select the curve and select the surface and make sure it is 93, so that it will cover the draft angle also. So again it's the same thing. Okay, so let's decrease this value to 5. Okay, we cannot create a class B surface like this. So what I'm going to do is delete this boundary. Let's create one more boundary. So we will be doing the class A surface. So the problem that we get is a very usual while creating the plastic products in CAD. Okay, so what we're going to do is we'll create the class E in 2 different segments, and then we will be trimming off or even joining them. Okay, let's click on this boundary, select this. I want the boundary from this edge to this point, this vertex to this vertex. Click on OK and click on this draft now with the draft direction, and select the curve and select the draft line like this. Make sure it is 3 degrees of draftness. Still it is showing error. Preview, still it is showing error. Okay, delete this boundary also. Okay, or else keep that boundary. Now click on this boundary and we will try to reverse the position, click on OK, and we will try other side. So we'll complete the other side and we'll come back to this again. Then click on this sweep, make sure it is draft with the direction, select the curve and select the tooling axis, make sure it is 5 degrees or 3 degrees, click on preview. Preview. Okay, let's let's cancel it and delete this boundary. Whenever you having the problems like that, so what we can do is select the boundary. So this process will lengthen our videos. Okay, so select the boundary, or else you can use the directly sweep command, and here the tab you can directly extract boundary. Okay, the first boundary I'm going to choose from this point to this point, reverse direction, click on OK, and after direction I can choose this 5 degree, preview. Let's wait. Okay guys, initially what we got is we have boundary, right? So let's delete it. So when we create a boundary for this outer edges, when I click on this smooth curve, select this, you can see this, you can see there are plenty of discontinuous, even the 0.5. You can see that, right? Okay, in order to work on this problem, what I have done is I have increased the maximum deviation. Okay, 0.1 up to. Okay, you can keep this as a curvature. Okay, preview. Now everything is in green color. Click on OK. Okay, this is fine now, and click on the sweep now, and with the draft direction, select the curve and select the tooling axis, and choose the draft angle as 5 degrees. Click on preview. Now it is forming, right? Preview. So this is fine for me. Click on OK. Okay, this is my class C surface, and unhide the class B also. Okay, the sweep you have created in wrong direction. Let's change this direction. Click on OK. Okay, for a trimming purpose we need the intersection between two curves, two surfaces. So what I'm going to do is I have to edit the class B also. Okay, so let's hide the class sweep and the class A. Okay, it is very simple also. Okay, let's create an extra bullet. Okay, delete this curve and right click, make sure the class B is defined on object. Okay, extrapolate, right click, create boundary, select this curve and from here to here, click on OK, surface, click on OK, click on this, extrapolate again, right click, create boundary, select the surface, first limit, second limit, change the direction, click on OK, and surface. So it is an error right here. So what I'm going to doing is set this boundary and change the second limit to this, click on OK. It is forming red, so right click, select the boundary, second limit, let's change it up to here. Okay, up to here it is also worked. Okay, that's fine. Let's change this value as 5 only, click on preview. Okay, now extrapolate again, right click, create boundary, set this, and I want to choose point right from here to here as a direction, click on OK, click the surface. Here it is forming the error again. Okay, the second limit we can change it, so let's cancel it. Okay, click on this boundary, set this and choose a boundary from this edge, this vertex to this vertex on reverse direction, click on OK, extrapolate, set the curve, set the surface, click on OK. Okay, extrapolate, right click, create boundary, or else create extract, whatever it is okay. Okay, this is fine. Okay, the class creation, we are doing in class B, right? So we have the interpolations up to this. I think this is, yeah. So what I suggest you to do is select the join feature and make sure the deviation is up to, margin distance is up to 1. Okay, now let's check the boundary. Okay, you are having the small boundary gap right at here, so which is not actually a boundary. So what I'm going to do is I have to work it locally. So select the extract, set this and this, click on OK, this, click on OK. Okay, hide all the join. Okay, so what I'm going to do is click on OK, click on OK, use the trim option, one surface over another, click on OK. Okay, this is fine now. So now unhide the join. Okay, hide this trim. So click on this join again and sub-elements to remove. I'm choosing this. Okay, cancel it. Join, set the surface, sub-elements to remove 1 and 2, and I want all this. Preview. Okay. Now unhide the trim. Click on the join, set this and this patch. Preview. Increase the deviation to 0.1. Preview. Now this is okay. Click on OK. Now class B is also fine. Okay. Let's see about class C. Okay. There is a proper intersection between all these faces. We can proceed with the other steps also. Okay. Hide the class B. And class A is also done. Okay. The next thing, we're going to join the class A with the class C. So we need to pay a separate geometry for that. So class, the name class A plus C. Enter. Okay. Make sure it is defining object and hide the class A. Select the join feature and select the class A surface and C surface. Click on preview. See, you will be having the discontinuities like this. So increase the value. You won't get the errors anymore. Click on OK. Okay. And hide the class B also. Next, we are going to trimming the class A plus C with the B surface. So we need to keep some geometrical for that also. So it's a name final trim. Enter. Okay. Okay, we can reorder it after completion this tutorial. Okay. So click on this trim option. Make sure you have hidden the class A. Okay. So trim class B with A plus C. Click on OK. Something gonna happen. Other direction. This. Yeah. We got our container. Okay. Okay, we got a container, so we can fill out material in this. Okay, so you can check before giving the fill command. Okay, click on this boundary and select the object. It will show the error like this. So it has shown the error. See the error once. It has no boundary. So for example, a 3D body, you cannot specify the boundaries for that, right? So it shouldn't be having any closer surface like that, right? So that is what the meaning of that error. And now I can go to the part designer page, and here you can see the close body option or close surface option. Select that. Okay, but before that you need to select this and define the object. Okay, select this close body option. Select this. Click on OK. After that, you can hide this final trim and class A surface also. Say you are having the final manufacturable part of this class A surface. Okay, so this is what the process that you have to follow when you are going for a CATIA tool test. Okay. Okay, let's reorder the tree structure. So first what I have done is right click and make sure the reorder children's. Okay, the first XYZ planes, that is okay. Axis system, that is also okay. The geometrical set, which is nothing but a class A. Okay, that is also fine. So after class A we have done the tooling axis, so that is fine. After tooling axis confirmed, we have created the class B surface. So after class B surface, we have created a class C surface, but it is gone somewhere else. Click on this class C creation and drag it up to here. Okay, then after we have done class A plus C, that's fine. Then after we have done this. Okay, the draft analysis, if you want, you can keep it as bottom, or else you can move it to below of tooling edges. Okay, okay, now it is okay. The tree structure is properly organized and everything is, and whenever I give the part to you means you can also easily understand. So what process what I have done, you can easily understand it. And also if you want to do any changes, okay, which is not preferred at all, but you can do the changes also. Okay, for example, in the class A thickness I have to increase, so go to offset, I can change the offset value. So right now I'm not changing because it will create a lot of errors again, so that's why I'm not going to doing that. Okay, so this is a process guys. Even though this is a small part, it takes around 40 minutes. Okay, so the next video we will be doing the same thing for the bumper also. Let's say how much time it will take in the next video. So until then, so keep watching our videos and keep supporting us in the YouTube. Thanks guys, thanks for watching our videos and have a good day.